Good morning. Could everyone take their seat? Sorry for the delay. We had some issues with the camera and audio setup. It always takes a while to get it going. This morning I want to talk about core data. Who here has heard about or used core data before? Subset of the people? Cool. So core data is the main persistence framework that you're going to work with in most iOS apps. And as I mentioned in the last lecture, it's not super easy to deal with at the beginning. It takes some time to understand the concepts that are involved working with core data, but it's actually really worth understanding the framework because it's very powerful. And as I said, you'll basically use it in almost every iOS app. Today I want to talk about the core data stack, so you have an idea which are the different APIs that you're going to work with the most and how do they work together, so you have a good understanding of how the framework is set up. Then we're going to talk about how you model data with core data. It's actually pretty easy. Xcode provides you with a visual editor to create a model file, to create relationships, to create properties. So that part is pretty straightforward. Then we're also going to talk about how you can actually add core data, the framework, to one of your iOS apps, either to a new app or to an existing one, because there's some issues that I have with the way that Xcode sets up the default project. So we're going to talk about that. And lastly, we're also going to talk about queries, which is one of the main features of core data that allow you to extract certain information from your database. So what is core data? It's a framework that allows you to work with almost regular Swift objects and to persist them. It provides you with a query interface, which means you can basically have similar to natural language queries, where you say, I want all users that have an age that is lower than 20, or I want all books that cost more than $50. So that query interface allows you to extract certain information from the database. And there are also a lot of advanced features that you're going to deal with if you actually build an app with core data that is maintained for a longer period of time. That involves such things as migrations. So you can pretty easily migrate between different versions of your data model. And as I said, if you have an app that's on the App Store for, let's say, a couple of years, then you're for sure going to make changes to your data model. And core data has a really good way of dealing with migrations. Then there are some other advanced things like delete rules. You can define how certain objects, how relationships are basically dissolved when you delete certain objects. And all of that stuff can be easily done in the data modeler. I also mentioned this yesterday when I first talked about core data. Core data is not necessarily a database. That is really more important when you go to an interview and you basically claim you're an iOS expert. Then don't say that core data is a database, because core data is just a framework that can work with different types of systems that allow you to store information. So you can use core data with something that runs in memory. You can use core data with a database. You can use core data with a file system. It doesn't really matter. Core data itself is just a framework that allows you to work with these different things, and it hides away which kind of storage you're actually using under the covers. And in 2 weeks from now, we're probably going to talk about this again when we talk about unit testing for iOS, because there it's pretty cool when you want to just test a database to actually create one in memory instead of creating one on disk. So very, very simplified, if you want to think about what core data is, it's basically this framework that sits between your Swift code and some persistent thing, whatever it might be. As I said, database, file system, or whatever you're going to use. Why do we want to use core data? Well, I said it can be complicated to use, but it is still the most powerful persistent framework. You have worked with Realm before, which is one of the upcoming new frameworks that is not provided by Apple. But Realm, for example, last time I checked, didn't really have migration features, and a lot of the features that are available in core data are not existing in third-party libraries yet. So at this point, core data is still the most powerful one. It's still used by a ton of apps, so if you work in an existing code base, you most likely have to deal with it. And it's also kind of that kind of black belt framework that you can learn how to use. And if you show people that you understand how core data works and you can work with it efficiently, you basically prove that you can pick up all other kinds of frameworks inside of the Apple ecosystem, but even outside of it. This really requires you to understand the concepts, to read the documentation before you work with it. So let's dive into what core data looks like. This here is the core data stack. These are all the different parts that are involved in working with core data. But the focus is really on these two parts here at the top. These are the ones that you're going to work with the most. Let's start at the top with the NS managed object. If you worked with parse before, then you can compare NSManageObject to PFObject. It's basically the main object that the framework gives you to persist data. If you want to insert a record into the database, you can create an instance of NSManageObject and give it a name, then set certain properties and then store it in with core data. You can also have custom subclasses, similar as in parse. So if you want to use your own data model and you say, I already have trip objects, I already have user objects, then you can make them subclasses of NSManageObject, and then they automatically become objects that can be stored in core data. So that NSManageObject provides all the relevant functionality for storing an object in core data. We're going to talk about it more on the next slides. Then there is an NSManageObject context. And I don't want to go into too much detail, but essentially that is where the objects that you create live until you store them on disk. So if you want to create a new object, you get a reference to a ManageObject context. Then within that context, you can imagine it's like a whiteboard or a scratch pad. You create these objects, and at some point you say, I want to save them. Then all of these objects from the ManageObject context go into the persistent store. So it gives you a scratch pad where you can work on objects before they actually get persisted, and then at some later point you save them, and then they go into persistent storage. These two parts here are a little bit less relevant at the beginning, and in most cases you won't really have to deal with them, but essentially the persistent store coordinator is the one that talks to your different persistent stores, which can be a database, a file system, in-memory database. And the idea here is that theoretically you could even have multiple databases in which you store your information at the same time. That is a very theoretical concept which you probably don't have to deal with that much. So mostly we interact with the ManageObject context. And as I mentioned a couple of times now, core data is a framework that hides away in which way the data is actually being stored in the end. So I basically talked about all of this already and kind of took the slide ahead, so I can leave the slide up here for reference. But NSManageObject is the main interface, the objects that you're actually going to store in the database. You can either work with NSManageObject directly, or you can choose to subclass from NSManageObject. NSManageObject context is your primary interface for creating objects, deleting objects, modifying objects, and then storing at a later point in time these changes to the persistent store. These two at the bottom are nice to know, but not necessary to work with. So what is a ManageObject? It's essentially a temporary representation of an object that is going to be stored in a persistent store, or even of an object that already has been stored in a persistent store. So if you, for example, want to get books that you stored in a database or in core data with a query, then what you will get back are NSManageObjects, and they will have exactly the same values that were stored in the database as at the time where you made the query. So they have a price and an author, for example. Then you could make changes on that NSManageObject, but at that point in time, they still only are in that context. It's not stored in your persistent storage yet. And then you can save that NSManageObject again through the NSManageObject context, and then it will be stored in the persistent storage. So it's basically always a temporary representation of what you currently have in the database. And as I said, we'll talk about it in a second, you can create a custom ManageObject subclass, which is useful and which you mostly should do. NSManageObject context, talked about that. It basically allows you all kind of operations, fetching objects, deleting objects, inserting them, updating them. So what does data modeling look like when you work with core data? So Xcode allows you to actually visually work with the data model. Here's a small example from the trip planner object. You can see these are different entities that have attributes, and you can even see the relationships between them. In this case here, it's very, very small, but you can see an arrow with 2 points in this direction, with 2 arrowheads in this direction, and with 1 arrowhead in another. That means this here is a trip that can have multiple waypoints, but each waypoint can only have 1 trip. So it's a one-to-many relationship. All of that information is visually inside of the data model. So that's a really cool part in Xcode. It is really easy to modify this. Here's a little bit bigger visualization of what it looks like. Essentially, the most things you're going to work with are attributes and relationships. So this here is a lot more similar to working with a relational database or working with objects than what you're doing on your API server right now. So when you create your core data model, you're going to think about what are the different entities that I have. Basically the same way you would think about which classes do I create for the objects I want to store, and then you think about the relationships between them. In this case, one trip has many waypoints. And then you define these relationships in CoreData. This is what the interface looks like for actually defining the relationships. You can select an entity, you hit the plus button here, then you can define to which other entity you want to create this relationship to, and then you can set some additional options up here. For example, you can say this is a too-many relationship, which means that one trip has many of this other thing. You could also have a one-to-one relationship, and yeah, that's basically all you can model here. What is also important to understand, to not get confused about, CoreData always wants to have an inverse relationship as well. So if you have trips that have waypoints, then the waypoint should also always have a relationship to the trip. That's just a requirement that CoreData gives you, but it's also really useful when you actually in your app, because in most cases you want to access things the other way around as well. So you always set up the inverse relationship. How do you establish a relationship in code? Here it actually gets really easy. So once you have modeled all of your data, you have created your NS-managed object subclasses, and you've done all the setup code, and let's say you have a waypoint and you want to assign a waypoint to a specific trip, then you can just say waypoint.trip equals, and you pass in a reference to a trip. So that is very much like you would do it in any regular code where you're not dealing with CoreData. And the cool part is, I just talked about the inverse relationships. These are handled automatically. So when I hand in a trip here, and I execute this line of code, then that waypoint will be added to this trip as well. So both relationships, both directions are maintained automatically. So how do you add CoreData to a project to actually get started? So the first way you can do it is when you create a new project, you have a little checkbox here at the bottom that says use CoreData. And that will essentially create a data model for you. It will enter the boilerplate code for setting up the CoreData stack. But what is not nice about the sample code, and actually every Apple developer agrees with that except the people that create the templates, is that it puts all of your code into the app delegate. And we're going to learn later on that we don't like to have code in large files that don't belong there. And the app delegate is really actually something that should just deal with things that happen when your app launches, when your app resumes, when your app goes in the background. But the CoreData stack should not be in there. So if you do this here, I have a recommendation that I'll link to on the next slide. I would take out all the CoreData code and put it into a separate class to make it a little bit cleaner. So if you start this way, put it into a dedicated class. I'll link to an article here that describes how you can structure that. And that's kind of the recommended way that all people that work with CoreData are doing it at the moment. If you want to add CoreData to an existing project, it's a little bit more complicated because you have to actually add the model yourself and the code yourself. Then here's a good link on how to do that for reference. So how do custom NS-managed object classes look like? So let's say you have created a data model with trips and waypoints, and now you actually want to create the Swift classes for these NS-managed objects. Then in Xcode, you can say, I want to create a new file. You select CoreData. Then you select NS-managed object subclass. Then you get a chance to choose the data model that you want to create the classes for. And in the next step, you can see all of your entities. So trips, waypoints, all other objects. And if you check all of them, then Xcode will generate Swift files for all of these objects. The Swift files will look like that. They're just typically regular classes that subclass from NS-managed object. And they actually create two files. The one is a subclass that is entirely empty. That's where you can add any kind of custom code that the class should have. And the other one is where the CoreData properties are created in. So all attributes that you create in CoreData, let's say the name of a trip, the duration, the start date, these are also created in code as properties, but CoreData puts them into a separate file, because if you add attributes later on, then this file will be regenerated. And if you would put your custom code in here, then your code would be lost. So that's why your custom code goes into this empty class, and the CoreData managed code goes into this extension class that gets regenerated every time you change your model. Not super important, but in case you're confused why there are two files, this is the reason. There's also some things to consider if you have your custom classes and you need to add behavior. For example, you want to change the behavior of how a property behaves by overriding a property setter or getter. Then you have to be careful. You should read this link here that has some rules about subclassing. I won't really go into the details of this here now, but basically you can imagine that the NSManageObject is a special class that has a lot of functionality that Core Data provides, and so it expects your object to behave in a certain way. And it's actually very similar with parse when you subclass PF object. So if you subclass, there are just certain things you can do and you can't do, and you should read about that in this link. Cool. How do you create an instance of something that you actually want to store in a database? Here is an example of the easiest way of doing it that is not super, super nice. The first part that is not great is the way how you get a reference to the managed object context, which is here again through the app delegate, because that is how the default project is set up. If you have your project nicely set up, you have some class called Core Data, whatever, and that allows you to get access to the managed object context. But that is what's happening in the first line. We get access to the context because that is what we need to create objects, delete objects, and so on. Once we have access to this context, we create a new object for entity name inside of this context. And here I have to provide the name of the entity that you want to create. So trip, waypoint, user, whatever. Here the not so nice part is that in this example, you actually have to pass in a string. And strings can always go wrong, so that's not super cool. So we're going to talk about a better solution on the next slide. But if you don't have a custom class, then this is the easiest way of creating an instance of one of your data model objects. Then you can set a property on here. And at the end, what you do is you save this context. Saving of the context can also go wrong because your object can be invalid in some ways. I'm going to talk about it a little bit more. That's why all of this here goes into an error handling block. And we're actually going to have a separate lecture on error handling in Swift 2 because it's a little bit different than it was before. But that's basically the big overarching structure is you get a reference to the context, you insert an object into the context, and you call save. And then it is stored. So two things that make me sad. That one up here, I already described the solution for that, have a separate Core Data class. And for this one here, I have a solution on the next slide that was provided by another iOS developer who had the same problem. And here the idea is that when you have your custom subclasses of NSManageObject, that you actually provide a separate initializer that provides the name of the entity for the class. And then from the outside, once you have set this up, you can create a new trip with this very simplified syntax. Say trip, and you just pass in a reference to the context. That way, every class knows its own name, and you don't have to type the name every single time you create an instance. And you don't have the chance of typing the name wrong and running into weird errors. Also, more for reference, you don't have to understand right now. But cool. As I said, try to encapsulate Core Data into a separate class, and try to not put it into the app delegate. How do you delete instances? Very similar procedure. You get a reference to the context, and then you call the delete object method on the context. And you pass in a reference to the object that you want to delete. And then again, at this point in time, the object is deleted, but it's still not saved to the persistent store. So only once you call save, that deletion is actually saved and the object is actually removed. If you wouldn't call save, then this object would just stick around, and the change would never propagate to your persistent store. Queries, also a very important part. They are called fetch requests, and they allow you to specify different attributes of objects that you want to fetch from the database. We've been building the API server now, so you already started to build queries where you find objects by ID, where you find objects that belong to a certain user. And fetch requests here are just exactly the same for Core Data. There are two ways of doing it. You can write these fetch requests in code, but there's also a visual editor that creates what you call fetch request templates. That's also a nice way of creating them. You can look into that if you're interested. That's a full example of how you would create a fetch request. Once again, primarily for reference. First thing we do is get a context. The second thing is you say which type of object you want to fetch. In this case, a trip. Then you set up the requirements. For example, I want a duration of 30 minutes. I only want to get trips that take at least 30 minutes or more. Then additionally, you can also define sort criteria. So you can say, I want to fetch these trips with this requirement, but all the trips that are returned shall be sorted by name. And once you have set all of this up, you can pass the query into the manage object context by calling execute fetch request. And once again, you have to wrap this into an error handling block. And if everything works out, you get results back of objects that match the query that you set up. Cool. Brief summary, core data, flexible, powerful, but you also really have to understand what's going on. So when you start working with core data, probably more beginning of next week. If you have any questions, ask as much as you can. Try to read the documentation and get a good understanding. Because here it's really that like 1 day of upfront learning will save you a lot of pain when you actually work in your app. So it's really worth understanding the concepts well. Cool. And I'll also link to other stuff that will make it easier to learn a question. It depends which type of store you're using. By default, what we're going to use is an SQLite database. So it's just going to store them in a SQL database. And you can actually even look at it. You can see columns, rows. If you worked with an SQL database before, it's basically just tables and rows and entries in there. Yeah?
So would it be better to describe core data as like an ORM?
It's also not an ORM because it's not really mapping objects to a relational database. It already takes objects. And it can also store them in memory. And it can also store them in XML. And yeah, it's kind of weird.
What other persistence layers are available on disk besides SQLite?
SQLite is the only database that ships by default. You can use core data with in-memory, XML, SQLite, and they also had a temporary one. I don't know if it's still supported, but it basically allowed you to write your own persistence stores. So you could basically take any database and just write a mapping between core data and that database and then store it in your custom backend. And some people toyed around with that and wrote a core data persistence store that was a web service. So basically, as soon as you called save, it would send off a request to a web server. Yeah. But I haven't really seen production use of that yet. So I don't know. Cool. Yep. Yeah. So the question was, what kind of stuff can you save in core data? So essentially, there are a lot of types, like strings, all the typical things are very easy to store. You can also store binary data. So images or photos you can store, but you have to encode them. The same as when you would store them on disk. That means you get a binary, you get some binary data, you have to encode it, and you have to remember in which format that document was that you stored before. And then when you read it, you have to restore the document. But essentially, you can store whatever you want because you can store binary data.
Yeah, like NS data?
Yeah, exactly. It's very, you can basically store NS data. Yeah. Yep. Oh, the guard keyword again? Since people asked me twice now, which slide was it at? Do you remember? Oh, here. OK. So we're going to talk about it separately, but guard is another way in Swift 2 to make sure that, that a value that is optional is not nil. And it does it in a different way. So what you say here is, I'm binding this context here into a variable called managed context. And I assume that the context exists. And if it exists, then the code executes as usual. If it doesn't exist, then the control flow jumps to this closure here at the back. And you can basically say, I want to return, then you jump out. So in this case, what it says is, if the context is nil, return at this point in time. If the context exists, then continue. And now you know that the context is not nil. It's like if-let, but the advantage is, with if-let, you have to basically put the rest of this code into the body of the if statement. And if you have a lot of if-lets, then at some point you get what do you call it again? There's a name for that, but it's Pyramid of Doom, I think. Yeah, exactly. Because your code starts to look like this. And guard basically lets you keep the indentation more or less sane. Yeah. If you want I mean, you can execute any code in here. Yeah. So the idea of guard is, I don't know, it just gives you a second execution path for the case that this is nil. And you can choose whatever you want to do in there. You can also put 100 lines of code in here, even though it would probably not make sense. Then you copy them in there? I'm not sure if, maybe we can discuss offline. Cool. Any more questions? This afternoon we're going to have a super small follow-up session on like some tiny bit more advanced topics. But yeah. Oh yeah, so there were two things that I didn't cover in here. One is how Core Data works with multiple threads. I'm putting it in the afternoon session because we didn't really talk about threading yet, so if there's over your head, it's totally fine. And the second one is how you can use multiple contexts, because you can basically have more than one context, and you can have parent and child contexts, and how that can be useful for your apps. Cool, thanks a lot.